Welcome everyone. In this video I'm going to do another product test or product review. So this is a promotional video, but I will try to do my best to make an honest review of this product. So in this video I'm going to test this multimeter which is provided by Banggood. So this is a product from Banggood and I will review this. And according to the box of this thing, this is a multimeter and oscilloscope, so it's a two-in-one product. And what it can do is it has a multimeter function, so I assume that it will show just the numbers, and then it can also show the waveform, and then it has screen, as it's written on this box. That's quite obvious here, as you can see, and then auto range, which is kind of expected from nowadays let's say modern products. So of course whenever you have a digital multimeter you expect to have the auto ranging function, but we will see it in the handbook if it has a manual ranging as well, so if you can use these buttons to select your range. And what is in the box is obviously this multimeter, and then we have a cable. We will check it how it looks. There is a pouch for the multimeter. It is made of a nice material, so you can put your multimeter in this pouch and save it from scratches. And then of course there is a user manual, and I guess we have to discover this user manual, or at least I have to do it just to see what are the main functionalities, but I will also try to use this as little as possible just to see how intuitive this thing is. So it has a relatively large display, I would say, but I haven't turned it on yet, so I don't know how large the actual display area is. And then there are 4 physical buttons here which we can press, I guess, to further select options or things like that. And we have this rotary switch which has millivolt, volt DC, voltage AC, frequency, and then there is 4 icons here because it can, I guess, measure capacitors, resistors, diodes, and then it has a continuity measurement as well. And MF is, I guess, it's microfarads, so it is for capacitors. And then we can measure AC milliamps and 10 amps. And of course, when it comes to the larger current, we have a separate connection for that, which seems to be fused. And then here we have the milliamp or millifarads connection with the yellow socket here, and that also seems to be fused, maximum 400 milliamps. And then we have a Cat2 1000 volts of input for voltage, resistance, and capacity. And then of course COM is the ground connection. On the back of this device we have some warning message, and then Cat3, Cat2. I don't know if it really works like that, but we will see. And then it says that it requires 3 AA batteries, which is not in the product. So of course I will have to find some batteries and come back to turn this thing on. Meanwhile we can check this cable. So we have these cables with some protective caps at the ends, so you will not stab yourself when you work with it accidentally. I can see that the quality is not the best here with the, I guess, injection molding, because you can see a lot of burrs here, but hopefully that will not influence the safety of this thing negatively. Quite rigid. And now this thing says Cat3 1000 volts, whereas this says Cat2 1000 volts. So it's a bit confusing, I would say. You can see it here. And the wire looks flexible enough, I would say. And then of course we have another set of protective caps on the other side which goes into the multimeter, and you can see that the banana plugs are buried under this thing, under this let's call it sleeve, which is really nice because you cannot accidentally touch it when, let's say, the other end is for some reason powered on. So that's nice, and yeah, it fits very well in the socket, so that's really cool. So I'm going to get a few batteries and return to you with a powered on machine, and we will see how it works. So we have the 3 batteries, and I just put on the cap here. And it's ready to work. So let's see how the display looks. And it's very good, I would say. Now I put it under the light on purpose. You can see the camera there, which is recording. So if I put it in the non-shadowed region, you can still see the display. At least I can see it through the camera. But if I remove it and put it here, you can see it even better. So it has a really nice bright display, as you can see. And let's see how this thing works. So I have my laboratory power supply here, which is of course not the most precise voltage source, but I just want to see how this thing shows the voltage values. And for that I leave this here. So now I set it exactly to 5 volts. And we will see if that gives us anything. So I set it to DC, of course, because we are using a DC power supply. And as you can see, 5.03, that's within the precision of this supply. So that's fine. And actually I have an even better voltage source, which might be more reliable than my power supply, the laboratory power supply. So let's try with that one. So what I have here is a precision voltage source with different voltages. So this is a voltage reference, let's say. And I have the factory values written here, which is probably measured by a precision voltmeter. Actually, this product is also from Banggood, so I will put the link in the description so you can buy it. And let's see what we have on the different sides. Yeah, this looks fine because this should be 10 volts, and as you can see, it measures exactly 10 volts. And yeah, we have like 5-ish volts here, 501, so this is also fine, I would say. And 2.5 volts, which is also, let's say, within the tolerance, at least for me. I can see if the millivolts works. As you could hear, obviously not. So this is too much for the device. So we are forced to use this. So yeah, we get 3 digits after the decimal point there. So 2.502. So actually this should show something like 2.497 volts. So it's a bit off, but I mean, a few tenths of millivolts is pretty nice for me. So that works well. And of course, we can check if we can get continuity thing working. Yes. And as you can hear, probably, you can hear that the beeping tone is quite loud with this one, so that's nice. So what I want to try now is measuring very tiny resistances, and for that, so here is a 1 ohm resistor, more or less precisely 1 ohm. It was a quite expensive one, so I use this as a reference, and I just use these wires and probes just to see how precisely we can read that 1 ohm. Now it's measuring, as you can see. It's really searching. And it shows 1.2 ohms. And I know for a fact that this is really precisely 1 ohm. So that's what the multimeter can do at this kind of range. But this is really like the lower end of resistance value, so we should not expect very high precision from this device. But yeah, it can measure it. It's like, okay, 20% off, but we are talking about 1 ohm and not like 2 kilo ohms or something, which is a more common value for a resistor. So it works. I would say it works. So ohm measurement is fine, voltage measurement is fine. And now I want to check these cables, because there is quite confusing information here. So if I turn this off and show the back panel, well, the device itself says 2 values, Cat3 and Cat2, 600 and 1000 volts. But what I'm more interested in is that this thing says 10 amps. So I should run 10 amps through this thing. I have a more beefy power supply for that. And I should see if it can really tolerate that 10 amps. So let's see how that works out. So I put together an experimental setup. So I will use another multimeter because I don't want to destroy this if something goes wrong. So I will use this multimeter to measure the current. And then I have a dummy load here, which is a 100 watt 1 ohm resistor. And then the power comes here, goes through the wire and then through the probe. It goes in the resistor, it goes out, and then it goes back to the power supply's other pin. In fact, it does the opposite way because this is now the positive, but yeah, it doesn't matter in this application. And here is a clip which holds a piece of thermocouple against the insulation, and here we measure the temperature of this insulation. Hopefully you can see it properly. And then I will just slowly increase the power, and by increasing the power we should see how this thing behaves. So here you should see the value now, and it's 1.4 amps. So I just increase this thing up until we get, let's say, 7 amps or 8. So 8 amps roughly. It still seems okay, but you can see that the temperature raises. But we are here for the experiment, so I should say let's go to 10 amps. And you can see that the temperature increases, but so far so good. And this is the temperature of the resistor. So I turn this off before I fry it. But it's still fine. It looks safe, and it's just 41 degrees. I mean, I don't see any softening so far. I can feel that it's a bit warm. But what I try to say here is that you can measure 10 amps with this probe. I just try to check it everywhere. You can measure 10 amps with this probe, but you have to be careful not to run it for hours. So if you just momentarily measure it, that seems to be fine, but I could see some temperature increase. when I try to measure it for an extended period of time. So now let's see if this device also can measure it. So we can test it as well. So the system is similar. Power comes in, goes through the resistor, and then in series with this resistor we have the multimeter. So power goes in the 10 amp input, and then it comes out on the COM, and then it's connected to the 10 amp source. So I power up this power supply and slowly go up with the current and see what happens. And as a confirmation, we can have another meter here just to see what's up. So this measures 2.7, 2.7. Now we should measure 5.69, 5.74. 7.4, that's fine. 9.3, 9.4 is the same. Actually, this multimeter here shows the exact same value as I see on my power supply, so from these two sockets here. Cable is like slightly warm, but it's okay. It's not softening, and it's not hot for touching. I mean, I'm really squeezing it, and I can hold my fingers on it without any issues. So this looks okay. So just approach 10 amps. So it can go slightly above 10 amps, as you can see, but we don't test that, how far it can go. So we can measure 10 amps with this thingy. That's really nice. So let's check the other functionalities of this. So of course the most exciting feature of this multimeter is its oscilloscope function. So when it comes to oscilloscope, I want to have two things. I want to change the function of time, so the time per div scale, and I want to change the function of voltage, so the voltage per div scale. So essentially the range. So I will see if I can do that, but I will do a very simple experiment and probably a bit dangerous. So I will just plug this in the AC outlet just there at my desk, and we will see how the waveform shows up if I don't get an electric shock. So let's see what happens. So it is beeping, but it doesn't show any particular wave here, as you can see. I can see that we see the 230 volts. That's fine. I am in Europe, so we have the European voltages here, and since I'm in Europe, we have the 50 Hertz, so 0.05 kilohertz. And I just try to do this intuitively because I don't know how this thing should work. If I press this up and down thingy, I can change the time scale actually. So if I press the up button, we actually arrive at the sinusoidal scale, which is really nice. So I can change the time division here by just pressing up and down. If I press the up, then the scale becomes more squeezed. And as you can see, there is a limit because now I keep pressing it and nothing happens. However, if I go the other direction, the sinusoidal wave stretches. So that's fine. So I could say that we reached the maximum range here. Also, there is this lightning symbol here, which I guess tries to tell me that, hey, you are measuring something dangerously high voltage, and that's true because I'm poking into the AC outlet. As you can see it also on the voltage and the frequency. So that's really nice. And now I have to figure out if I can change the voltage scale. So for that I will check the manual. So here in the manual it says waveform of voltage measurement. So then of course it tells you how to plug in the probes, that's fine, and how to reach this menu. And then of course we just went to the voltage function here, AC voltage, and then it says that we should touch the test probe, the test point with the test probe. I'm already doing that, so the probes are plugged in an AC outlet, and then I should hold down the this function, and that is done because we are already in the waveform menu. But I cannot really see if I can change the range. So it seems that the range should be automatic. And just to test this a bit more and use it in a safer way, I will bring my waveform generator, signal generator, and test how this thing works. So here is my function generator, and I have already connected it to this multimeter. And what we can do here is I can provide different kind of signals, and what I do here is I'm providing 10 kilohertz or 10,000 hertz and 5 volt sinusoidal wave. So that's what we can see here now. And I can change this wave to a square wave with similar characteristics. And I will try to change the duty cycle of this thing if that changes anything on the display. So now the duty cycle is supposed to be 0. But it seems like that it doesn't change anything particular in this. And I don't know if that is because of the chosen time scale, because I cannot see what kind of time scale is being used. So that's a bit hard. Now I'm at 99% or 100% of duty cycle, but the signal doesn't really change here. So either I messed up something here on the wave generator, or something is wrong with this. So I go back to the sinusoidal wave and I try to change the frequency just to see how this can go. So now I'm supposed to run at 1 kilohertz. And of course I have to change the time scale. But of course, here we have this very interesting thing that if I mess up the time scale, as you can see it here, then we see the waves in a different way because the sampling and the frequency of the signal kind of in a wrong, let's say, harmony. I don't know the good English expression for this, but you can see that this waveform is not what we expect. But here, if I manage to find this thing, or if I press the auto button and the multimeter finds it for you, then you can see the wave very nicely. So let's change to square wave. We can see it, that's nice. This should be PWM pulse, but it doesn't show up nicely. This is a triangle. And then this is a partial sinusoidal wave. You can see that it drops after half or 1/4 of wave. What else we can do here? This is a half wave. And it's nicely symbolized here. And yeah, I could do this for days, but you can see that we can see the signals as they should be. But what I miss here is that I cannot see the time scale, what kind of time scale is being used. So it's very hard to manually find the good wave form. And I cannot see the voltage scale. Of course, I see what kind of voltage is being read, which is kind of an effective voltage, I guess. But I cannot change the voltage scale as well. And there is also no kind of a trigger, if I can see, because sometimes the wave just floats around. So I would not call this an oscilloscope, but it's more like a waveform meter, because it misses the basic oscilloscope functions. So yeah, it's nice and it's useful that it can show the frequency, but I just cannot accept this as an oscilloscope. So now I increase the frequency of this thing and try to find the upper limit just for fun. And now it's being overloaded, so this is out of limits. And I'm trying to feed it with 1 megahertz. But if we check the handbook, then the frequency should be maximum of 20 kilohertz. But if I want to measure the frequency, then that can go up to 5 megahertz. And then here it works. So I have 1.05 megahertz. I don't know if I can show it in any way. But that is being measured here perfectly, but we cannot make the drawing out of it, as you can see. But that's pretty much normal based on this. So if I go back to the technical parameters, then we have 20 kilohertz as the maximum frequency here. So let's achieve that at least. So this is 20 kilohertz. And if I try to go beyond this, let's say 21, it still works, but I can see that the wave becomes a bit funny. So it might not be the best idea to push this to the limits. I mean, I will not damage it, but it just doesn't show any useful stuff. And now I use 50 kilohertz, and of course it goes bananas, as you can see. So yeah, 20 kilohertz. You can use it for general applications, but this is not an oscilloscope. 20 kilohertz is laughable for an oscilloscope. You would expect more like 20 megahertz from a good oscilloscope, but of course you cannot compare it to an oscilloscope because it is not an oscilloscope, it's just a graphical multimeter. So I would say that the description of the box is not too correct when it states oscilloscope, because it is not, but it's a really nice, graphical multimeter. So I skipped a few functions, so I'm just going to cover those. I'm just curious how it can measure the capacitors. So I will just find a few capacitors and see if I can measure them. So let me prepare that. So I cleaned up the table a little bit because I want to test the capacitors as well. And for that, I'm getting rid of the original cable because it's just a bit too meticulous to use it on the small pins of a capacitor. So I have my homemade clip thingy here. So at the end, which goes into the multimeter, it is just a simple banana plug. And then I have these extremely flexible wires, silicon wires, and this is a 26 AWG wire, but I'm not going to carry too much current through this, so it's fine. And then I have these clips, so it's very easy to attach it to tiny legs. And one thing that we have to be careful about is that if we want to measure like higher capacitance, then we put it in the MF way here on the dial. And then there is a very funny way how you should connect the cables. So instead of COM and let's say MF, you have to put the negative in the V ohm cap part, and then MF is the positive lead. So that's what we have. And now I have a few capacitors in a larger capacity here, and then I have some nanofarad or picofarad things. We will test them as well, a few of them. So first, let's try this 220 microfarad capacitor. So I just attach one leg here on the negative, of course, and then another goes on the positive. And now we just, I guess, we have to wait. And after a few seconds, I get almost exactly the same capacitance here. So this is a 220 nominal, and we see 221. So I'm very satisfied with that. That's nice. Let's try a bit higher value. This is 390. So positive lead goes on the positive pin or leg, and then the negative goes on the negative. and let's see what this gives to us. So as you can see, we have to wait a few seconds, and after it settles down, and this is 378. So it's a little bit off, but it's still acceptable for me, I would say. So now let's go to the, let's say, picofarad range, and let's see if 56 picofarad can be measured in this mode, or if not, then we will change. So this is 56 picofarad nominal value. So let's see what that does if we connect it. So of course we have to wait, and then we can see that this is pretty much out of range, which means it's too small value. So we have to switch modes. And for that, just to check if we are correct, then here it says in the capacitance measurement part of the handbook that we have to change the wires. So what I do, I first turn this thing off, and then negative goes to the COM, positive goes to the cap, as it is shown here, and then I just go to the capacitance part. And now I have to change this. And now we are in the capacitor mode. And this was, if you remember, 56 picofarad. And it seems that doesn't work. So now I try to remove the capacitance of the wires by pressing the rel button without connecting the capacitor to it. So now this kind of tears it. So this will be the 0 value. And now I connect the capacitor here. And I still get funny values. So I guess this is a too small value for this measurement. So 56 picofarad is out of range, and we can check that if that's true or not. And that's true because the bottom of the range is shown as 51 nanofarad, so we are 1000 times off. So then I can change, and let's say I measure 100 nanofarad. So this should be 100 nanofarad capacitor. And we should be able to see something on this. And it's almost 100 nanofarad, so it can measure, but of course it cannot measure, let's say, 50 picofarad. That's just too small, and that is also, of course, stated in the manual. So 51.2 nanofarad is the bottom of this range. So that's just too small value for this, but it works, as you can see. So we can measure capacitors, let's say, within a reasonable range, which is nice. And then one very important thing that I also want to show you, that as you can hear, it has a very, very annoying beep. At least I don't really like it, as you can hear it. So what you can do is that you can turn this thing off, and then you can hold down the select button at least for 2 seconds, and then you turn this thing on. So now it says quiet mode on, and if you check, there is this speaker with the X in front of it, which says, or which suggests that this is the quiet mode. And now if I change the different modes, it will not beep. Let's see if it will beep in the continuity mode, despite the fact that I have the quiet mode. So it doesn't do that. So then it turns it off entirely, and it will not work even in the continuity mode, because that's what I would expect, that it doesn't beep when you overload it or something, but it beeps when it should beep. in this continuity mode. But yeah, it doesn't matter. So yeah, all in all, this is a nice multimeter. It has a very, very good readable screen. That's one of the things which I should highlight about this. And the waveform mode is very nice, but it's not an oscilloscope. I should emphasize this. So you can really nicely show the waveform of different signals, which should be a periodic signal. So you cannot have just any kind of random noise or something like that recorded, but you should have some kind of periodic signal, like the sinusoidal wave coming from an outlet, or something from a wave generator, or a PWM signal, or something like that, which is, yeah, periodic. I could have, let's say, disassembled this thing. Okay, so despite my efforts, this screw is destroyed. I tried to save it, and I tried to remove it with another tool, but it just crumbled. I don't know what it is used for, this material, what is being used for this screw, or these screws, but one really just too weak. So I'm guessing that I'm not going to show you the interior of this, because then I should need to pry this open. But you can see that this screw is pretty much destroyed, so I don't know what to do about it. So I'm unfortunately not able to show this. I could pry open this, but then I would probably destroy the enclosure and probably something inside as well, because I'm guessing that this bolt here also holds the circuit board, and then if it holds the circuit board, when I try to force it open, I might destroy it, or I might damage some parts of the tracks. And since the bottom part is close to the connectors here, I'm not going to try to, let's say, pry it open, because I could destroy the terminals or the fuses or the connections for the fuses or something like that. But I'm pretty sure that there are other people outside on YouTube who have already tested this device and opened it. So you can always find them, and you can always refer to their experiences regarding the interior of this device. So sorry for that, but this screw here is just a really low quality thingy. So maybe that could be also revised for a future model of this thing. But at least this thing still works, as you can see. So yeah, unfortunately I was not able to show you the inside, but hopefully that will not be a big problem. This thing has a really nice manual, and it helped me a lot, because some things, for example, how to connect the different cables in different kind of measurement modes, were not that obvious, especially for measuring the capacitance. So always refer to the manual. It's written with a quite understandable language. So it's really nice, and it takes like 1 hour to go through it and understand everything, and you can test the different functions. So it's a very good product for hobby users, for measuring just general things, getting the waveform of different kind of signals, not as an oscilloscope, but really just to show the waveform. You don't have really the freedom of options that you can have in an oscilloscope. So if you really need to measure signals, just buy an oscilloscope. But this is good as an everyday multimeter with a good display. So don't forget to check the link in the description, or my website, where I provide a lot of pictures of this product. And you can also find the promotional links from Banggood, so you can buy this device at a discounted price. And I hope you will like it if you buy it. So I hope that this video was useful to you. I try to show a lot of features of this device, and try to reveal its weaknesses and strengths as well. So I hope you learned something, and see you in the next video.